Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be covering 5.4, which is looking at converting between quadratic forms. We've already learned all the skill sets necessary for this assignment in mainly Unit 4, a little bit in Unit 3, but rather than having to solve a quadratic, we're just converting simply between the three forms. So there's technically less steps, but we'll go through it and see what it looks like here. So of course, if you remember, there are three different forms that we have from quadratic functions, and this goes all the way back to as far back as Unit 2 when we introduced quadratic functions, but you have standard form, you have factored form, and you have vertex form. If you go back to Unit 2 when we first introduced this topic, you can see the slide that shows each of these forms and how to go from one to the other. Going from standard to factored form, as the name might imply, that involves factoring. If I'm going from factored form to standard form, that's probably the easiest one. You just need to multiply using the box method, any way that you see fit. If you're going from standard form to vertex form, that is completing the square. And if you are going from vertex to standard form, then that involves multiplying. Now, sometimes you will be asked to go from, let's say, factored to vertex. And so basically to go from vertex to factored or factored to vertex, you're going to have to go through standard form is the easiest way to do it. Okay? So let's look at this here. Start out with some easy examples. If I have a function, let's say x minus 3 times x plus 5, and I ask you to go to standard form. So it's in factored form. I want it in standard form. So you could use the box method, FOIL method, distribution method, however you prefer. I would do x times x times 5, negative 3 times x, negative 3 times 5. Of course, always combine any like terms you have. And just by doing that, I've converted it from factored to standard form. All the examples in this assignment are going to be with coefficients of 1. It would be the same process if you had a leading coefficient other than 1, but just to keep it simple, because we're doing all this online, it's just going to look like these types of examples. Okay? And I could ask you to go the other way. Let's say f of x equals x squared plus 10x plus 24. So you need to factor this using any of the techniques that we learned. I would use the x. So you're looking for what two numbers multiply to get 24, which is C, but add up to 10, which is B. Those two numbers are 6 and 4. Therefore, this in factored form is x plus 6 times x plus 4. So that conversion is usually the easiest, going from standard to factored or factored to standard. A lot of students are okay with that. Similarly, if I'm asking you to go from, let's say, vertex to standard, that's pretty straightforward because it's just doing the multiplication. So let's say I had f of x equals x minus 2 quantity squared plus 3. You would first need to expand this binomial using any of your techniques that we've covered. I would use the shortcut. A plus or minus b quantity squared equals a squared plus or minus 2ab plus b squared. If that's confusing, remember you can always just write it out, x minus 2 times x minus 2, and do it that way. Once you do that, you're going to end up with x squared minus 4x plus 4. That's all of this. And then you still have the plus 3. So, of course, you're going to finish it by combining like terms, which is x squared minus 4x plus 7. So, like I said, most students are okay with doing examples that look like 1, 2, and 3. When we get into, let's say, going from vertex or standard form to vertex form, then that gets a little bit trickier. We talked about completing the square in Unit 4, so if you need a review, I would go back and watch those videos. Let's say I had x squared plus 8x plus 15, for instance. So remember, what we're looking to do is be able to create that perfect square. You have a table of values from unit 4, but remember the shortcut is that I want half of b value squared to be here. So I want 4 squared to be there, which would be 16, but I have a 15. So what do? We change it to be a 16 by adding 1. And then to keep it balanced, we're going to subtract 1, right? So all I did really was change 15 into be 16 minus 1. Now that I've done that, now I can write this as a perfect square, which is that half value, x plus 4 quantity squared minus 1. So that's how we go from standard form to vertex form. Oh, sorry about that. We'll fix that in post. So then if you're asked to go from vertex to factored form or vice versa, you got to go from one through the other. So for instance, let's say I had something like f of x equals x plus 2 times x plus 9, for instance. Or, well, I'll change that to do x plus 10. So this is in factored form. If I ask you to write it in vertex form, first I want it in standard form. So just like we did in number 1, I'm doing x times x times 10, 2 times x, and 2 times 10. Combine like terms. So now we have x squared plus 12x plus 20. So we went from factored to standard. Now we're going to go from standard to vertex. So just like we did in number 4, I'm going to take half of 12 and I'm going to square it to see what I want for my c value. 6 squared, of course, is 36. So I would have to add 16 to that to get 36. And then because I added 16, I would have to subtract 16. Now that I've done that, the first 3 terms here, I can write as a perfect square. So that is half of 12x plus 6, quantity squared, minus 16, and that's vertex form. You've really already seen all of these. The idea between converting between the different forms is being able to identify the key features of your graph, your vertex, your intercepts, your y-intercept, your axis of symmetry, all of that. So sometimes it's helpful to be able to convert between the 3 forms. But that is it for today, guys. If you have any questions, please reach out to me. Have a good day, and I will talk to you soon.